Hi everyone, I am Soumojit Chatterjee and this is TLE Eliminators. Welcome to the post-contest discussion of today's Codechef contest. We will discuss 5 problems of today's Div 2. So before starting the discussion, someone please confirm whether I am completely audible and visible or not. Okay, great. So before we start with the discussions of today's contest, I would like to tell you that you all may have a look at this CP31 sheet, which is actually prepared by TLE Eliminators. And in this sheet, all our mentors have actually compiled 31 questions and each question teaching a very unique idea for every rating till 1600. We will update it for higher ratings also soon. But for up to 1600 problems, you can actually have 31 problems which from the Codeforces problem set, which actually all teach a very unique idea. So you all do not need to waste time choosing the right set of problems, and you can actually solve these problems to get an idea of how problems come in that particular rating. So is that fine? You all can have a look at it. So now let us start with the first problem of the contest. So this is the first problem. It says Swish Game. So Tufan is playing an exciting game where there are n rings, and for each ring, Tufan can either swish or pass. The goal of the game is to achieve at least k swishes. The game will end immediately when at least one of the following two conditions is met. The first one is that Tufan has finished all the n rings, or the second one is that it is impossible to win the game anymore. This means that it is impossible for Tufan to get at least k swishes regardless of what he does with the remaining rings. Okay, fine. So we were given the value of k, the number of swishes he must achieve, and we remember the sequence of moves which is given as a string s of length m. Fine. And the question asks that given that Tufan ended the game after exactly this sequence of m moves, what could be the value of n be? Okay, fine. So let me explain the question once. So this is the question. So in the question, the input is a string s of, so the input is a string s of length m. So we are given a string s of length m as input. And what does this string looks like? This string looks like basically lots of s and p's combined. So you have an s, a p, or a s, and all these things are compiled. Fine. And the entire length is told that it is m. Now the question says that the initial objective was to actually find k swishes. K swishes, or basically ks. So basically the game starts and he wants to find ks. So he plays this sequence of operations. And then if at any moment he sees that, okay, I have, so read the question once. So it says that the game will end immediately when at least one of the following two conditions is met. When Tufan has finished all the n rings, or if it is impossible to win the game anymore. This means that it is impossible for Tufan to get at least k swishes regardless of what he does. Okay, fine. So that means, so there are n rings, and then these are the sequence of games which he plays. If he exhausts all these n rings, then he will stop. Otherwise, he will keep on playing this game. And he will also stop if he ever reaches a position where he finds that, okay, now if it ever reaches a position where it sees that, okay, if all the remaining things I make a swish, then also I cannot achieve my target k, then also it stops the game. And the question is to find out that what is the length of n basically. So basically, how many rings were there? So is the question clear? Anyone with doubts in the question itself? Okay, fine. So if the question is clear, let me explain the problem. So basically, I've been given a string which comprises of S, P, S, and so on. Fine. Now let's do one thing. Let's count the number of S. So suppose CNT is basically the number of S in this string. In this string. And this string is of length M that is given. So this string is of length M. That's fine. Now there are few things to consider. It has been said that the target was to find k. Target is to find k number of S. Fine. But it does not mean that if I have ever reached the target, then I will stop. I will stop whenever I have exhausted all these rings. So I've exhausted all these n rings, then only I will stop. Or I will stop when I see that, okay, I have played the game till m operations. So the length of this is m. So I've played the game till m operations. But now whatever I do in the remaining part, I cannot get k swishes. Then also I stop. Okay, fine. So let us break it into cases. So the first case is what happens if the number of swishes is already greater than k. So what happens if the number of swishes is already greater than k? Anyone? So basically you were playing and then you saw that, okay, the number of swishes you made, that is already greater than the target. Correct. So if the number of swishes is already greater than the target, then what does that mean? That means then why has the game ended? So always ask that why has the game ended? The game can end only when there are two possibilities. So why has game ended? The game can end only due to two reasons. The first reason why a game ends is that basically you have exhausted all the n values. So basically you have played all these n operations. All the n rings have been exhausted. In that case, the game stops. Or the game stops when your count value is so low that it can never reach k. But this is not that case. Look at this. So the game stops when the count value is so low that you can never reach k whatever you do in the remaining operations. But that is not the case here. Here count is itself greater than equal to k. That means here the game has stopped. The game has stopped because you have exhausted n basically. So you have exhausted n. That is the reason only this game has stopped. So if you have exhausted n, so you have basically made m operations, and you have exhausted n, that simply means that the value of n is equal to m here. So this case is simple. So if you see that, okay, count is greater than equal to k, then n is basically equal to m. Fine. Now let's look at the second case. So the second case is that count is less than k. So if count is less than k, that basically means that the number of swishes we have got is basically less than k. Okay, fine. But then if the number of swishes is less than k, then why has the game ended? Again, the same question. Why has the game ended? Why did not we continue it for longer? Why has game ended? In this case, the only reason the game has ended is because whatever you do in the remaining operations, you can never win the game. So that means, think about this. You had a total of n rings. So you have a total of n rings, and then you have played the first m operations of the game. You have played the first m operations of the game. And this is the position, basically out of these operations, you know that, okay, CNT, the count number you have already counted, that, okay, count number of them are swishes. Fine, count number of them are swishes. So if this is the case, so like you have played m operations and you see that okay, CNT number of them are swishes, then what is the maximum number of swishes you could have got if you have played this operation till n times? Anyone? Is it k minus 1? Like I'm asking that, okay, you have played m operations and then you have got CNT number of swishes up to here. Fine. So now here the question says that whatever you do here, basically you will never reach k. So that means this is a tight bound. So okay, so the total number of swishes, that means, so that basically means the total number of swishes I can actually make is k minus 1. Because if the total number of swishes I could make was greater than equal to k, then the game would have not stopped here. We would have continued the game, right? Because then it is possible to reach k moves. So the only reason why the game has stopped here is that the total number of swishes you can get, the maximum number of swishes you can get is k minus 1. In order to maximize the total number of swishes, you basically have all these s here. So that means whatever you do in the remaining part of the game, even if all of them are swishes, still you could reach only till k minus 1 swishes. So what does that mean? That means that, so you had these m operations. So there are CNT number of swishes here. So basically there are CNT number of swishes here. And here there are n minus m number of swishes. And CNT plus n minus m, that is basically the total number of swishes you can get, that is k minus 1. So CNT plus you have this n minus m, that is basically k minus 1. Fine. So that means you can write that n is nothing but m plus k minus CNT minus 1. So in this case, the value of n is m plus k minus CNT minus 1. So basically you have taken CNT number of, so basically you have found CNT number of swishes here. But even if you find all these n minus m to be swishes, still the total number of swishes you can get is only k minus 1, and that is the reason why the game has ended. So even if you look at the code, just a second. Yeah, so even if you look at the code, this is what I've done. I've taken n and x, I've taken the string, and then I've counted that, okay, how many swishes I have seen. So basically this counts the number of swishes I have seen. If the value of count is greater than equal to x, that means the game has ended because the number of rings have been exhausted. So we just print n. And in the other case, the game has exhausted because it was never possible to win the game. Basically, it was never possible to reach x number of swishes. So we just print n plus x minus CNT minus 1 as the expression we discussed. So we just print this expression n equal to m plus x minus CNT minus 1. X and k are interchangeably used in the discussion. So is that fine? Okay. So let me explain this once again. So basically the question says that you have played the game till m operations. So there are total of m operations you have made. And it says then the game has ended. So you have made a total of m operations, but the game has ended. Okay, fine. But the question also says that the total number of rings you could have played is n. So that means you could have played a total number of n operations, but you have played only m of them. So you are given m and you have been given conditions on where the game can stop, and you have to tell the value of n. So I said that, okay, there are two cases. One case is that the number of swishes I already see is greater than equal to k. If that happens, then why has the game ended? The game has ended because simply you must have exhausted n. Because the second reason, there are two reasons why a game could end. First, you have exhausted all the n operations. Second, second is that whatever you play in the remaining operations, you can never basically get k swishes, and that is the reason the game ends up early. So here you have already got k swishes. That means the only reason the game has ended is basically you have exhausted n. So in this case, we print n is equal to m. Fine. Now this is the second case. This basically says, so this is that case where basically the game has ended early. So the game has ended only at m operations. The game has not continued for this entire n operations because you have realized at this position that you can never win the game. So basically you play the game at till this position, and then you realize that, okay, whatever I do in this remaining part, I can never win the game. So you just throw here. So you just do not play after this. Fine. Now my argument is that what could have happened here that you have realized that, okay, I will not play the game again. Since you have decided here that I will not play the game again, that basically means that you must have realized that, okay, if I take all these count number of swishes I've got till now, and if I do the best part here also, then also I cannot reach k swishes. So that means at this part, you have realized that, okay, I can get only k minus 1 swishes. So the total number of swishes I can get is k minus 1. After that, it's simple algebra. So basically count CNT number of swishes up to this part. And from this part, I've assumed that, okay, I do even the best. So it is basically even I do the best part in the remaining thing, then also I cannot get k swishes. So the most number of swishes I can get here is n minus m. And still, if you add CNT plus n minus m, it is less than k, it is k minus 1. So that gives us this equality. And finally, we get this expression of m. So is that clear? Guys, anyone? Okay. So assuming there are no doubts on this one, let's move on to the next problem. Okay, so this was the next question. The question says that Tufan loves white walls. He recently painted a wall with some colors red, green, and blue. However, he realized that the wall doesn't look as bright and white as he imagined. So Tufan's wall has length n, meaning it has n positions placed in a line, and each position can be painted in one color, either red, blue, or green. Okay. So you are given a string S of length n, denoting the initial coloring of the wall. And a white wall is defined as a wall where every consecutive set of positions with length divisible by 3 contains equal number of R, G, and B. Okay, fine. So this is given a formal definition. And the question says that Tufan can repaint a single position on the wall to any other color R, G, or B in one operation. And your task is to determine the minimum number of operations required to transform the given wall into a white wall. Okay, so let me explain the question once. So the question first defines what a white wall is. So what is a white wall? So the question says that suppose you are given a string S. So you are given some string S. So these are the characters of the string, say S1 to Sn. It says that take any substring which is whose length is divisible by 3. So suppose I take this substring of length 3k. So the length must be divisible by 3. Then it must have k reds, k greens, and k blues. So I would call a wall white if whatever subarray you pick of length 3k, some length divisible by 3, then it should have equal number of red, green, and blue. If this happens for all subarrays of length divisible by 3, then I will call it a white wall. Simple. So is the definition of a white wall clear? Everyone? Okay, great. So if the definition of white wall is clear, now the question is simple. So the question says, so this is the question. The question says that you are given some string S. So you are given some string S, which is S1 to Sn. In one operation, what you can do, in one operation, you can erase some character and replace it with anything. So you can replace it with R, G, or B, basically. Okay. So that is what you can do in one operation. So in one operation, you erase something and you write a R, G, or B. And the question says that what is the minimum number of operations? So basically minimize the number of operations to make it a white wall. So basically you are given a wall which is arbitrarily colored. You need to make a white wall, and in order to make it a white wall, you have to do it in minimum number of operations. Fine. Okay, so is the question clear? Anyone, any doubts with the question? Okay, so I assume that the question is clear. So in that case, now what can we do? So basically we are given a subarray of length. So that means now let us first try to analyze white walls. So how do white walls look like? How do white walls look like? So let me take the first three characters. Fine. So in the first three characters, that is a valid subarray of length 3. So it should contain exactly one red, one green, and one blue, if the wall is red, right? So it should be some permutation of RGB, correct? So let me say that, okay, the first three characters, for example, suppose are RGB. Fine. Now think about this. So I have just assumed that, okay, suppose the first three characters is RGB. Then what do you think the fourth, fifth, sixth characters would be? Any idea? Anyone? I know that the first three characters have to be some permutation of RGB. So, okay, I say assume that, okay, suppose the first three characters are R, G, and B. Then what should be the other characters of the string? If the wall is a white wall, any guesses? Okay, let me show you. So look at this. So you know that, okay, this is a substring of length 3. So there should be equal number of reds, greens, and blues. So that is fine. So this part is a white wall. So this part basically validates or satisfies the condition of a white wall. Now think about this array. Think about this subarray. This subarray is of also length 3. So it should have exactly one green, one red, and one blue. But you already have a green and a blue. That means the only character which can come here is red, right? If any character apart from red comes here, then this part will not satisfy the condition of a white wall. So this has to be R. Fine. Now this same logic actually repeats. That you look at this part of the array. You have already got a red, you have already got a blue. So the only character which can come here is green, right? So the only character which can come here is green. Fine. Now look at this part of the array. You have already got a red, you have already got a green. So the only character which can come here is blue. There is no other character if you want to satisfy the conditions of a white wall. So it should be RGB and then again RGB and it goes on. So this is a very beautiful property that if you have a white wall, then the first three characters are basically any permutation of RGB. But in order to satisfy the conditions of a white wall, that same permutation basically needs, which basically tells us that there are only 6 different possibilities of a white wall. So it says that there are only 6 types of white walls. And how do they look like? They basically look like that you have some permutation of RGB and it repeats. So you have an RGB, and it goes on. Or maybe you have a GRB and then again you have a GRB and this goes on. Fine. Is that clear? Anyone with any doubts? Okay, fine. So that means there are only 6 types of white walls present in this world. Fine. Now suppose I have told you that, okay, you are given the string S. So suppose basically you are given the string S. I said that, okay, the string S is given to you and we need to make it, convert it to a white wall, right? So suppose I want to convert it to RGB and so on. Okay, it is my wish. So suppose I want to convert it into RGB, so on. So it goes like this. Then what is the minimum number of operations required? Any idea how can we compute this? What is the minimum number of operations required? So I have been given a string and I need to convert it into say a fixed string RGB, and so on. Then what is the minimum number of operations required? How can we compute it? Anyone with any idea? Exactly. The simple way to compare it is basically look at it character by character. So that's something like this. Just a second. Just a second, everyone. Maybe I'm facing some issue. Okay, fine. So basically, my idea was if you want to compare it, so basically you look at this character by character. So you have this string S1 to Sn, and you compare it with RGB. So you have these characters here S1, S2, and then you compare it with RGB and so on. So now you basically count how many characters differ. At every index, if the characters differ, then basically you would require an operation here. So that is the way you can find the minimum number of operations. So basically the final solution is something like this. So here is the solution. I know that there are 6 possible types of white walls. So I have 6 types of white walls, right? So RGB, RGB, and it goes on like this. Okay. And then I can have RBG, RBG, and it goes on like this. So basically you iterate over all possible permutations of RGB, and then you get 6 different possible permutations. For every permutation, you actually compute. So for every permutation, you compute that what is the minimum number of operations required. Okay, you can do that in order n time because that requires just a simple for loop and checking that, okay, how many positions are there where the characters of this string and the given string differ. So basically you compute all these values, all these operations and take the minimum of them and return it as the answer. So answer is basically the minimum of all of them. Is it fine? Is the logic clear? Guys, anyone? Someone please confirm if it's clear. Great. So even if you look at the code, so look what I have done. It's simply straightforward. So I've taken n as input. Fine, I've taken the string as input. And then I've initialized answer to a large value n. So because I know that the answer or the number of operations required would be obviously less than n, that's fine. And I've taken this vector of characters, which is basically my key. So which is RGB, and then I've sorted it. And then I basically iterate over all possible permutations of this key. Fine. So when I'm iterating over all possible permutations of this key, I'm taking the minimum with the answer and finally printing the answer. So what do I do? In this op function, so basically I'm taking that op s comma key basically computes what is the minimum number of operations required to convert s to this array, to basically this white wall, like some permutation of this key repeated forever. So how do I check that? I basically count the number of changes required. So basically I see that the number of positions where si is not equal to pattern I modulo 3. I could have concatenated pattern a lot of times and create a length of create a string of size n, and then I could have done the comparison. But this also works fine, right? That instead of actually creating this long pattern where everything is repeated, you just take the index modulo 3 and check it. So that is fine. So anyone with any doubts with the problem? Is it clear for everyone? Okay, fine. So if that is the case, then let's move on to the third problem of the contest. So this is the third question. It says that there are n positions along a line, each of which contains either a building with positive height or a volcano. Fine. You are given this information as an array A of length n, where ai equal to 0 represents a volcano at position I, and ai greater than 0 represents a building with height ai at position I. Fine. Initially, the lava level is 0, and every second, all the volcanoes erupt simultaneously, increasing each of their lava levels by exactly p. Okay, and then lava behaves as follows. Suppose the current lava level is x, then lava will flow from left and right from each volcano till it reaches a building whose height is strictly greater than x, at which point it will stop flowing. Okay. For each I, determine the minimum time at which building I is completely submerged under lava. Okay, so let me explain the problem statement once. So the question says, that in input, they will give me an array of integers a1, a2, dot 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 an. Fine. Now they say that every index basically represents a building. So this a1 basically represents that there is some building with height a1. Fine. So this is the, so this, suppose this is the ground, and then there is this some building with height a1. Fine. And then I can have, this is the building with height a2, for example. Then I can have building with height a3, and it goes on. Fine. So there are lots of buildings. So there are also buildings here. Suppose this is an, and so on. Now there are few interesting positions. So suppose this is the index I. So this is ai, and suppose ai equal to 0. What does that mean? The question says that if ai equal to 0, that means there is a volcano here. So this is nothing but a volcano. Fine. And the question says that every second, this volcano basically erupts out, and it increases its lava level by a height of p. So it increases by its lava level by a height of p. That is what the question says. And the question asks that what is the minimum time required for some building, say suppose what is the minimum time required for this building to be completely submerged under lava. And you need to tell the answer for all these buildings from A1 to N. Fine. Now, how does lava flows? So the question says something like this. Basically, so this is something very intuitive, or something which is very obvious from the structure of the problem. So suppose this I have this building A1. Fine. And now I have this building A2. And suppose A2 is greater than A1. And then I have a volcano here. So a volcano here, A3. And then suppose I have A4 here. I have A5 here. And suppose I have A6 here. Great. Now the question says that at every step, what basically happens is that the lava level increases by P. So suppose at t equal to 0, there was no lava, it was at 0. At t equal to 1, this lava level increased by P. Fine. At t equal to 2, this lava level again increased by P. Fine. At t equal to 3, it again increased by P. So these height differences are all P. At t equal to 4, what happens? It not only it increases by P, but then it also takes or covers basically this building, the fourth building A4. Fine. So this is obvious from the diagram that here is the point where the lava height has basically increased, and it has submerged this building A4. Now there are few important things to realize. First of all, look at this building A6. This is a very small building, right? But even if it is a very small building, it has been not submerged at t equal to 4. Look at this. This building's height was even smaller than the building of A4. So basically, if this is A6, then look at this, that A4 was actually greater than A6. But still, this building 4 got submerged before A6. Why? Because there is this building of huge height which basically guards this building from the volcano for some time. That is the reason A4 will submerge before A6. So is that clear? Like how does the lava flows and what is the question? Okay, guys. So if that is clear, let me think about this. So the question says that for all I, so this is what the question says, that you have to say for all I, when does the ith building submerge? When does ith building submerge? Fine. So that is the question. Great. Now let us, so we have to answer for some ith building. So let me consider the ith building. So suppose this is the entire array. Okay, just a second. Okay, so suppose this is my entire array and this is some index I. Okay, so there is some building here. Fine, whose height is AI. Great. Now note that the most important volcanoes for I is the immediate volcano to its left. So suppose this is Li and this is Ri. Fine. So these volcanoes, suppose Li is the nearest volcano to the left of I and Ri is the nearest volcano to the right of I. Remember that if AI ever submerges someday, then it will be basically because either of this volcano or this volcano. Lava from at least one of these volcanoes should come up and actually submerge this building I. Right? That is the only reason why this building may have submerged. So that is fine. So when do you think? So when do you think that? So let us consider one volcano first. Let us consider the volcano on the left. Okay, fine. So its height increases by P every time. Okay, fine. So now tell me one thing that, okay, suppose all buildings in this range are smaller than AI. So basically you have small buildings here. Suppose this is the case, you have small buildings here. There is no large building which guards AI between Li and I. Then what is the time required for this building, for this Ayat building to submerge? Anyone? So if all the buildings between the Ayat building and the volcano are basically small, so they are smaller than AI, then what is the time required for the Ayat building to submerge? Any guesses? Exactly. It should be seal of AI by P, right? What basically happens is, so what does basically happen? So this lava's height increases by P every time. Okay. So basically, suppose after T time, what is the height of this height of this volcano? So at time T, the height of the volcano is, the height of the volcano is nothing but T into P. And in order for the ith building to submerge, basically TP needs to be greater than AI, or T basically needs to be greater than AI by P. Now, since T is always an integer, we can say that, okay, the minimum value of T is seal of AI by P. It will take this much time. It will take this much. If all the buildings in between are small, then this lava will take this much time, AI by P seal value of time, to actually submerge this building under lava. So that is clear. Now, think about this condition. So suppose I have again the same setup. I'm considering the ith building. So this one is height is AI. Fine. But now in between I have some large building. Okay. In between I have some large building, say AJ, and the volcano stands here. So here is the volcano. Fine. Li. So here is the volcano. Now, and suppose all other buildings are small. So all other buildings which we consider are smaller than both AI and AJ, for example. Then what is the time it takes for the lava of this volcano to reach here? Like, then what is the time this ith building actually submerge? Any guesses? Is it still seal of AI by P? No, it's seal of AJ by P. So basically what happens? Now, if this building I has to submerge, then this lava has to actually first has to increase its height, and it has to first cross this building J, right? It has to cross this building J. The moment it crosses this building J, it will come and overflow this. But it has to increase its height till J. So now, in order to submerge I, you have to submerge basically AJ. So now the time required, now the time required would be seal of AJ by P, if that is clear. Okay. So that basically gives you a hint. So that basically says that, okay, I have this ith building AI. So this is AI, some ith building. And then I have two volcanoes, one at Li and the other one at Ri. Right. Now the idea is that you look at the largest building in this range. Okay. So look at the largest building in this range, call it MX1. And look at the largest building in this range, call it MX2. Fine. Now, basically, in order for this volcano to actually submerge AI, it has to basically fill up to a length of MX1, right? And in order for this volcano to submerge AI, it has to fill up to a length of MX2. So it is something like you have two large buildings standing here. the maximum. This is the largest building. Okay, so this is mx1 and this is mx2. In order to submerge AI, this volcano has to basically submerge this mx1 first. And in order to submerge AI, the right side volcano has to submerge mx2 first. So my basic idea is that you take mx1, you take mx2, take the minimum of them. Because when does this ith building submerge? When even one of these buildings submerge basically. So the smaller building will submerge first. So here suppose mx2 is larger than mx1, then this lower volcano will submerge first and it will submerge this ith building, right? So take the minimum of mx1 and mx2 and the answer should be simply. So what should be the answer? The answer should be simply minimum of mx1 by p, the seal value of this. So it be, and mx2 by p. Isn't it? Basically, this is the time it takes to submerge the ith building from the left volcano, and this is the time it takes to submerge the ith building from the right volcano. So is that clear? Everyone? Any doubts? Okay, great. So let me first show you the code. So here is the code. So if you look at this, so I've taken n and p as input. I've taken the vector as input. So I've taken the vector as input. And then I basically make the L and the R arrays. Okay, fine. So the L and the R array basically stores that, okay, for the ith index, it stores that what is the maximum value it sees on the left before a volcano comes. And for the rth, and Ri stores that what is the maximum volcano it sees on the right, maximum building it sees on the right before a volcano comes. So basically, these are two passes for the left part and the right part. So basically, what I've done is I've tried to compute the values of mx1 and mx2. So how will you compute them? So suppose I've been given some array. Suppose I've been given this array 3, 5, 0, 2, 8, and 6, and again a 0 and a 4, for example. And I basically need to compute this L array. So what does this L array store? The L array stores that what is the, just a second. Yeah, okay. So this L array stores that what is the maximum you see here. So basically what is the maximum you see here till a volcano arrives. So for this 8, what is the maximum you see here till the volcano arrives? It's 8 itself. So let me take a better example. So suppose I have a 10 here also. Fine. So what does Ri store here? So basically Ri for 8, Ri will store that what is the maximum value it can see before a volcano arrives. So it is basically the maximum of this length, which is nothing but 10. So what do? I compute this L array. So how this L array is computed? That initially you keep all of them infinity. So this is something like that there is no volcano here. So you can think about it like that, okay, there is an infinite sized building which guards it from everyone, right? And an idea to think about it to handle edge cases. So fine. So this is infinity. This is infinity. So this is a volcano. Just ignore this. And here the maximum value it sees is basically 2, right? Here the maximum value it sees is basically 8. So basically this stores the maximum you see in this range. This stores the maximum you see in this range. So basically what does Li store? Li store that for some index I, what is the maximum I see in this range such that here there is a volcano. So look at the nearest volcano and then what is the maximum building I can see here. So that is basically the value of mx1. So these are simple linear passes. If you look at it carefully, so what I've done, that I've said that, okay, if AI is 0, that means I've found a volcano. So reset everything. Set H is 0, Li is 0. Okay. Now if AI is less than H, that means the maximum does not change. So you just set Li equal to H. And if this case is not satisfied, that means AI is greater than equal to H. That means AI is the new maximum. So in that case, set H as AI and Li as also AI. So I do it for the left and the right parts. And finally, what I did, I basically took the minimum of Li and Ri, as we said, that the minimum of mx1 and mx2 of those two buildings will be actually basically submerged first. and then I just print the CL value of OK by P. Okay. So is that clear? Anyone with any doubts? Okay, great. So, okay, how did I think of this approach? So basically it was quite intuitive, right? Like, I do not think it had much of secrets. Like if you think at why does this Ayat building actually submerge? Then you will realize that okay, this Ayat building, how can lava arrive here? So if there are these large buildings on the left and right of it, then lava can arrive only when someone breaks this building and goes here, isn't it? So that means that this volcano has to somehow reach and break this building and then come here. So that is the reason. So you basically need to compute mx1 and mx2, look at the smaller building, and then what is the time it takes for the lava to break this building, isn't it? I think if you would have drawn these things, and instead of having this looking at this complex notation, so if you look at the problem, then the notation is a bit complex, that it reaches a building whose height is strictly greater than x. But then if you actually try to draw it on pen and paper, you will realize that okay, the conditions look something very obvious. Like it is very similar to how water flows, isn't it? Like if you would have buildings here, and then there is a water source here, that is the exact same way how water would have flown, right? It would have first filled till here and then it would have overflown and come here, isn't it? Okay, great. So if that is clear, let's move on to the next problem of the contest. So this was the fourth problem. So it says that Tufan knows that the vault's passcode contains n number to enter, with each number being an integer between 1 and k. And while exploring, he found a scrap of paper that gave him some information about the passcode. Okay. So in particular, Tufan has with him an array A of length n, where each AI is either 0 or an integer between 1 and k. Fine. AI equal to 0 means no information is known about the ith digit, but the vault is a bit faulty. It will open if either the correct code is entered or the reverse correct code is entered. And then it says that in an attempt to open the vault, Tufan will try every possible passcode that matches the information in lexicographical order. And the question asks that in the worst case, how many attempts must Tufan make before the vault is executed? Okay. So that's fine, right? So let me explain the problem statement once. So basically they say that the input is an array of integers again. So it is an input is an array of integers a1 to n. And they say that this is a special password. So they say that a1 to an is basically a password. Fine. So there are some values of a1 to an given and some AIs are 0. So suppose this a3 is 0. So you have again these values and then again you have a 0. Fine. Now the question says that all AIs are between 1 and k. Right? So all these digits must be between 1 and k. Fine. So these digits are between 1 and k. And then there are some pieces of missing information in between them. Fine. Now that means that we need to rewrite this position with something between 1 to k. I have to rewrite this with something between 1 to k, and then I have to test. So this is the password of some vault. So what can I do? I can basically rewrite it with some position from 1 to k, and I have to test that, okay, is the password correct or not? So this is something like, suppose the array given is 1, then a space, or basically a 0 is represented by a space, for example. So I've given 1 space and 3. And I've said that, okay, the value of k is 4. So if the value of k is 4, you know that, okay, every digit can be between 1 to 4. So what would be a brute force attack? So if you have to find the password, what would have you done? You would have checked all these combinations, right? You would have checked 113, 123, 133, and 143, isn't it? You would have checked these 4 conditions, and then you would have said that, okay, if one of these conditions, if this is correct, then at least one of these 4 should be a password. So that means in worst case, you will take 4 attempts to actually find the password, isn't it? But the question says something even more. It says that suppose 113 is the password. So the question says that if 113 is the password, then if you feed 113 or 311, they are the same thing. So basically it says that the vault is a bit faulty, and even if you feed the reverse of the password, then also the vault will open. Okay. So that means if I have two valid passwords, 113 or 311, and if I have tested it already with 113, there is no sense testing it with 311. You can throw away this apart. Okay. So now the question asks that what is the minimum number of operations required in the worst case? Okay, so what is the number of operations required in the worst case to basically find the password? So is the question clear? Guys, everyone, is the question clear? Okay, fine. So if the question is clear, so let me show you with an example of what they are trying to say. So let me take this small array, which they have given 0, 0. So this is a sample example. So this is a sample example. And they say that, okay, you have been given a password where both the values are 0 and the value of k is given 3. So that means both these pieces of information you do not know. Okay. Now, what is the in the worst case, how many operations you will take? You will basically try to fill it up with all values, possible values from 1 to 3, right? So 1, 1 is a possible trial. 1, 2 is a possible trial. 1, 3 is a possible trial. 2, 1. 2, 1 is a possible trial, but we will not do it. Because remember that you have already tested 1, 2. So feeding the password and the reverse of the password is the same thing. That is what it has been said. So you've already fed 1, 2. Then there is no point in feeding 2, 1. So you do not feed this. Okay. Then comes 2, 2. Great. Then comes 2, 3. Then comes 3, 1. This also you will not feed because you have already fed the reverse of this password. 3, 2. This will again also will not feed because I already fed the reverse. And then finally comes 3, 3. So how many passwords or trials? 1, 2, 3, sorry, 1, 2, 3, 4, 5, and 6. That means we need to actually make 6 trials in this case. So is that clear? Yeah, so it isn't, yeah, there are 3 into 3, a total of 9 ways. But then you see that, okay, some of these ways are actually reverse of each other. So we will consider them only once. Okay, so how can we count this? So what do we need to count? Basically, suppose, suppose I have been given this array, right? I have been given this array. Most of these values are filled. Suppose most these values are filled A1, A2, A3, A4, A5, and A6. So these values are filled and some of them are empty. 0, 0, 0. These are empty. Okay. Suppose the number of zeros we have counted and that is Z. So the number of zeros I have counted, that is Z. Okay. So not thinking about anything else, what is the number of sequences I can make? What is the number of trials I can make? Like if you forget about k to the power z, exactly. So basically, if I have to fill all of these with some value from 1 to k, and then I have to test that, okay, is it a correct password? So that means the total number of trials is k to the power z. Fine. But does that work? Because when you say that the total number of trials is k to the power z, then you would have not considered the fact that there will be some passwords which will be reverse of each other, and you would have not to and you need not actually consider them, because if it's a reverse of another, then you do not need to test it by again feeding it. Its reverse has already fed it. So if it were a correct password, it would have actually given the correct answer, right? So that means we need to somehow subtract. So from this k to the power z, we need to subtract the number of the number of passwords the number of passwords whose reverse is also present. Basically, something like we have to now we have to actually reduce the number of valid passwords. The number of valid passwords whose reverse is also valid. Whose reverse is also valid. Okay. So what does that mean? That basically means that okay, you had some passwords, that is k to the power z, but then out of these there were some valid passwords. So what do I mean by valid password? A valid password means that it should satisfy these constraints, that the first index should be a1, this should be a2, this should be a3, a4, and here in this position of 0 there can be anything else. Fine. So look at those passwords which are valid, but the reverse is also valid. Like consider this. Here 13 is a valid password, but its reverse 31 is also a valid password. So these things which we have actually overcounted. So these things which we have to reduce them or subtract them from k to the power z to get the answer. Correct? So is that clear? Like, is the basic idea clear? Like, what are we trying to do? Okay, fine. So now let me take an example. So suppose I take this 40060. Okay. So I have been given 4, 0, 0, 6, and a 0. Let me look what is the value of k they have provided. Okay, so they say that the value of k is 10. That's fine. So let me write it here. The value of k is equal to 10. Great. So now, first, what is the value of k to the power z here? So what is the value of k to the power z? So basically there are 3 positions. So the value of z is 3. And then their k is 10. So k to the power z is 1000. So that means there are actually 1000 trials which we can actually make, right? There are 1000 trials which we can actually make. Okay, so let me try making a new test case. Just a second. This probably is a bad example. Let me think about, forget that test case for now. Let us think about this test case. So suppose you have a 4, then you have a 0, then you have a 0, and then you have a 3, and then you have a 0, and then you have a 6. That is fine. So now think about this test case. So the value of, and suppose k is 10. So is k is 10, the value of z you can easily count is 3. So that means k to the power z is 1000. Perfectly fine. Now, here, do you see, but we may have done overcounting, right? There were maybe there were some valid passwords whose reverse were also valid, and we have unnecessarily counted it 2 times in this k to the power z, right? But think about this, that if I suppose I had some password which is valid. So if I have some password which is valid, it must be of this form, right? It should have 4 here, it should have 3 here, it should have 6 here, and then it should have some values k1, k2, k3 here, which I do not know. They are from anything from 1 to 10, right? Now look at its reverse. Its reverse is 6, k3, 3, k2, k1, and 4. But look at this, that if this is a valid string, then its reverse is not valid. What do you mean? What do I mean by not valid? It basically does not maintain the property that, okay, that the first integer should be 4, the fourth integer should be 3, and the last integer should be 6. So here there is a mismatch. That means in this array, it is never possible that, okay, I have some password which is valid, whose reverse is also valid. Because if I have some password which matches this pattern and the reverse also matches this pattern, then I have to reduce them by 1 because I've counted them 2 times in this k to the power z. But here, I do not find it like that. Why? Because here, there are 2 positions which differ, which are complementary of each other. Think about palindromes. So these are 2 positions which are complements of each other and they differ. So that means if you take the reverse, either the reverse will not be valid or the original string will not be valid. So that means in these cases, we do not make any duplicates. So is that clear? Okay, fine. So if that is clear, so basically what do I mean? What do I mean? That I mean that I have been given some array A1, A2, say AN. Fine. And then suppose there is this counter I which is moving forward, and then there is this counter J which is moving backward. If I ever see, if I see that, okay, AI is not equal to AJ, AI is not equal to AJ, and both AI and AJ are non-zero. So AI is also not zero, AJ is also not zero, but AI and AJ disagree on them. If this happens, that means either, so if a password is valid, its reverse will not be valid, right? So in that case, we have not done any overcounting. So in that case, the answer is simply k to the power z. Fine, everyone agrees with this. Okay, great. So if that is fine, now let us look at other cases. So now I have no such index which basically disagrees on each other. So every index agrees on themselves. So basically I have arrays like 4, 0, 3, 0, and then I have suppose again a 0, and then I have a 4. Right. So look at these positions. So this agrees with this. This value agrees with this. Like there is a 0, so it does not disagree at least. Here we can feed anything. Fine. So we have already seen that, okay, the total number of combinations possible, that is k to the power z, which in this case is 1000. Great. But then there are some positions, but now we need to reduce, basically subtract those cases which we have overcounted. Which cases we have overcounted? Those cases where the password is valid. So basically I filled some numbers here, here, and here, and that is valid. Its reverse is also valid, because there was no meaning counting it 2 times in k to the power z, right? So we will try to remove them. So note that, so suppose I have this string and I reverse it. So suppose I have this 4, A, 3, B, C, and 4. And I reverse it. What do I get? I get 4, C, B, 3, A, and a 4. Isn't it? So that, what does that mean? First of all, this this should also match. So this should match this pattern. If this pattern needs to be matched, then the value of B has to be 3, right? So basically, if you see a 3 here, then its complementary position should also be filled with 3. When you are trying to count the number of cases which are not overcounted. So if this is 3, then this is also 3. Fine. We are remaining with these positions where we have actual freedom, where both the points which are complementary of each other are basically empty. There you can fill anything, isn't it? So basically, so you have this array 403, 004. You know that, okay, if I need to make a valid string such that the reverse is also valid, I have to fill that position with 3. I do not have any freedom there, right? So I just fill that position with also 3. Great. Now these are the positions which I have freedom in, right? So suppose there are C such positions. So suppose that the number of such positions is C, where both the complementary indices are basically 0. Then what is the number of passwords I can make? Anyone? Exactly. So basically, like if I count that, okay, C is, I just count that, okay, C is the number of positions. So like C is the number of matching. So here C is 1. In that case, we can make k to the power 2c. So k to the power 2c is basically the number of, it is basically the number of configurations or number of passwords whose reverse is also valid. Basically number of passwords which we have counted 2 times. Which we have counted 2 times. So which we have counted extra. Right? Because look at all these configurations. In all these configurations, you filled k with something. So you basically say, you basically filled k with something, but then you have also taken the reverse of it. So basically you have suppose filled this with 1 and then you have filled with 3. But in other case, you have taken this with 3 and this with 1. So these you have overcounted. They were reverse of each other. So basically k to the power 2c are those cases where you have overcounted. So does that make sense? Okay, great. But then this still does not work. There is a point to remember here, that basically that there are some palindromes. There are some palindromes. So basically consider all those k to the power z strings, k to the power z passwords which we initially got. In those passwords, what we said that there were some valid strings. There were some valid passwords whose reverse was also valid. And we have counted them 2 times. Whose reverse was also valid. And we counted them 2 times, right? So we will try to reduce them. And we saw that, okay, number some valid passwords which we have counted 2 times. That is k to the power 2c. Fine. But note that in these k to the power 2c, there are actually k to the power c ways. Like what did I explain here? I said that, okay, you would have maybe you would have taken a 1 and a 3 here. Then in other case, you could have taken 3 and a 1 here. And these are just the same case because this will be handled when you take the reverse. But look at those cases where suppose you have filled a 1 and a 1 here. Its reverse is also 1 and a 1. So they are the same string. So in these cases, you have not made an overcounting. So if you have a 1 and a 1 here, so in the reverse also, you basically have a 1 and a 1. So in these cases, you have actually not overcounted. So in that case, we do not need to subtract anything with the number of palindromes. What is the number of palindromes? Basically, there are C positions. And in all these C positions, if you fix a choice here, the choice here also gets fixed. So that means there are k to the power C choices, right? So that means out of these k to the power 2c, there are basically k to the power c number of palindromes. And in those palindromes which we have not overcounted. So those palindromes which we will actually basically not consider in our overcounting. Right. So if you look at the code once, then probably it will get a bit clear. So look what I've done. I have taken n and k as input. I have taken the vector as input. And then I first check that, okay, is there some index I and n minus I minus 1 such that vi is not equal to vn minus I minus 1? Because if that happens, and then I also count the number of zeros. So if that happens, then I've set this flag pal to false. So if that happens, then I know that the answer is simply k to the power z, isn't it? Great. Now what do I do is, I basically count the number of matching pairs. The number of pairs where both vi is 0 and vn minus I minus 1 is 0. So I have counted them. So this is C and T. Fine. So now I have taken these two values, k to the power 2 times count and k to the power count. Okay. So ignore this part and look at here. What I've done is, so these are the total number of ways which I've counted. Okay. So, and out of these were palindromes. So actually the extra thing which we have counted is nothing but total minus palin. Because out of all these k to the power 2 into count, the palindrome things which we have counted only once. The overcounting was only done for things which were not palindromes. So we found out those number of passwords or patterns which were not palindromes. And then we simply divided by 2 because we would count it only once. And I finally subtracted from k to the power zeros to get the answer. So is that clear? Okay, fine. So if there are no doubts, then we may. Okay, let me show you the code once again. So look what I've done. So this part is just a second. Yeah. So here is what I've done. I have first checked that, okay, is the string a palindrome? So basically, I have said that, okay, is there any complementary position where they differ? If there is any complementary position where they differ, then we have not done any overcounting because no reverse just matches the pattern. So in that case, we simply print k to the power zeros. Okay, so that is fine. Next case, what we have done is we have counted the number of positions where vi and vn minus I minus 1, both of them are zeros. Because if both of them are zeros, that means there are two complementary positions where both of them are zero. And in that case, basically I have done some overcounting here. So how many cases were there? There were k into 2 times k to the power 2c number of cases. But how many palindromes were there? There were k to the power c number of palindromes. Now, look at that. Out of these total cases, this palindrome number of cases you have this palin number of cases you have counted only once. So those, for them we have not done any overcounting. So I reduce them. So I do basically total minus palin. So these are the extra things which we have counted. So basically these things are something which we have counted twice. So I basically remove them, divide it by half and remove them. So I do not count them twice. I just take them once and then I finally print the answer. So is that clear? And you will get the code in the description. So that is not a problem. Okay, fine. So let us finally move to the last problem of the contest. So this is strange Nim game. So it says that Alice and Bob are playing a strange variant of the Nim game. What does the Nim game is? There are n towers with the ith tower having AI rings. On their turn, a player selects a tower I that contains a positive number of rings and a positive integer d such that d appears in the decimal representation of AI. The game ends when all rings from all towers are removed. The player who removed the last ring wins. Alice always makes the first move and both players play optimally. Okay. So let me just first explain what does this mean. So Nim's game is actually a very famous game. And this is nothing but a strange variant of the Nim's game. So how is it? It basically says that you have some values a1 till an, right? You have some values a1 till an. What can you do in one operation? So Alice and Bob are playing the game. So there are two people, A and B, Alice and Bob, who are playing the game. Alice makes the move first. So what can he do? Basically, if he sees some a3, then look at, suppose this a3 value is 5048. Okay. Look at all the non-zero digits in it. So look at 5, 4, and 8. Okay. You can, at a one step, decrease its value with either 5, 4, or 8. So I can choose 4 and then I can decrease it and convert it to 5044. Fine. So both Alice and Bob alternately take turns and keep on playing this game. And finally it is asked, then finally the player who at the end cannot make a move loses the game. So the player who makes the last move actually wins the game. Okay. So is the variation of the game clear? Like, how do we play the game? Is that clear? Okay, fine. So now the question asks something which is not very trivial. It says that you have to process Q queries and updates of the following types. It says that first of all, you have to handle two types of queries. In one query will be given a range LR and you have to find that how many non-empty subsequences of these towers are there that will result in Alice winning if the game is played with only the towers in the subsequence. And then the other type of query is just you basically change the value of the array to X. So we need to handle two types of queries. In one query, what can we do? We would be given some range L to R, and then we have to say that how many subsequences are there. So how many non-contiguous subsequences are there on which if the game is played, then Alice wins the game. So this is one type of query. And in the other type of query, I would be given some index A2 and I have to change its value and keep on write X here. Okay. So is the question clear? Any doubts with the question at least? Okay. So if the question is clear, so let me tell you that, okay, this basically this version of this problem actually required a few of the prerequisites, which are not very trivial and which I think are not very popular. One thing which was required to solve this problem is this Grundy's theorem. So this theorem, so this is the CP algorithms blog, and this is probably the best resource which you can refer to learn Grundy's theorem. So the basic idea of Grundy's theorem is that whenever you have a impartial two-player game, so basically whenever you have a game which is impartial, impartial meaning that, okay, I have two players on which the game is played, and there is no partiality between the power of the players. The only partiality is that who starts first. So Alice starts, then Bob starts, and both of them do exactly the same thing. So if you have an impartial two-player game, then Grundy's theorem says something like that. It first says that, okay, so let me give you the basic ingredients of Grundy's theorem. It is something not very standard. So it says that in a game, every state of the game can be represented by a number. So let me call this Grundy's number. So it's G of S. Okay. And Grundy's theorem states that if you make moves from some state and it reaches to some, and suppose you reach to some other states, S1, S2, S3, and S4. Okay. Then you can write transition something like this. So you say that G of S is mix of G of S1, G of S2, and so on. So basically, Grundy's theorem says that whenever you have such a game, whenever you have such a two-player game, what you can do, you can basically assign a number to every state of the game in this fashion. So basically for every state of the game S, you assign a number G of S. And how do you write G of S? G of S is the mix of the values you get from the states you move. So basically these are the transitions you make. And for every transition you look that, okay, what are the values I have? Fine. Now, Grundy's theorem says something very interesting. It says that if G of S is 0, after you have made these transitions and you have found the value of G of S for all state, then if G of S is 0, you are losing, else you are winning. So if G of S is 0, you are losing, else you are winning. So that is what Grundy's theorem states. So the proof I am not discussing, but the idea is something like this. Whenever you have a game, for every state you assign a number. How do you assign a number? In this fashion, write recursion in this fashion. After the number is assigned, it is very easy to check. If you are given some state S and I ask you that, okay, will you win from here? You just need to check that, okay, is G of S equal to 0 or not? Okay, so is that fine? Okay, so there is also one very important thing which the Grundy's theorem says. It basically says, look here. What does it says? That it says that if you have dependent games, so if the games are not independent, then you have to do a XOR of it. So this is something like that. Suppose you are playing the game on some integer n. So suppose you are playing the game on some integer n. Okay. So you have this value G of n. Fine. So now suppose this this game can break into two parts. Okay. So it suppose breaks into a part where you basically break this n into n by 4 and n by 4. And it also breaks into a part where you break this n into, say, n by 2 and n by 2. So these parts are independent in themselves, but among those they are dependent, right? So basically Grundy's theorem says that, okay, you take the XOR of their Grundy's value. So you take G of n by 4 XOR G of n by 4. Something as XOR here also, because these are dependent. And then you take the mix of all these numbers. You take the mix of this, and so on. And you find out the Grundy's value like this. So at the first glance, I understand that if you do not know the theorem at first, it may be a bit overwhelming. But the idea is something like this, that if you are playing a two-player game and you are at some state S, then if you go to some all independent states, then what do? You basically take the mix of all these numbers. Okay, the mix of all the Grundy's numbers, and then you get the value of G of S. But now, if you go to some state where there are actually dependent components, then in order to find the Grundy's number for this state, you take this bitwise XOR of everything. So that is my G of S1. So you take all bitwise XORs inside, compute this G of S1, S2, S3, and S4, and then take the mix of them to compute S. Okay. So is that clear? You could actually read the proof here. It is actually a very interesting thing. And in many problems which are very far related from, probably you can actually use them, use this idea. And the proof is actually quite interesting. Okay, so if you look at the code, so we will read the code a bit and then we will try to understand what I have done. So see what I've done. Just a second. So the idea is something like this. That initially look at these values AI. So these AI values are between 1 till 2 times 10 to the power 5, isn't it? Okay, fine. So that means, so what does that mean? That means that I can do some sort of dynamic programming, and then I can compute these Grundy values for all AI. I can compute the Grundy value of all these AI, right? How can I do that? So basically you run a loop. So you run a loop from I equal to 1 till 2e5, right? So for every I, so suppose, for example, suppose I is 5048, right? Then you look at all the transitions it can make. So from 5048, you could remove 5. You could remove its digits, right? That's what the question says. So you can get a 5043, you can get a 5044, or you can get a 5040. So these are the three integers you get. To compute their Grundy values are already stored in DP. Take their values and find the mix of them. So take the mix of them, and that is the Grundy value of that is basically the value of G of I. So that is what I have done here. If you look here, I have set Grundy 0 as 0. Then I have run a loop from 1 till 2e5 plus 5. And at every step, what I'm doing, I'm basically storing I minus digit. So that is basically the original number minus the digit in some array nums. And then I finally rewriting the nums with their Grundy values and taking the mix of them. So if that happens, then that basically means for every value of AI, I have the Grundy value for it. Okay. So think about this, that for every value I, so for every value of I basically have the value of G of I stored. Right. So now if I ask you a simple question that, okay, suppose you are given some array A1, A2 till AN, then how will you check who will win? How will you check will Alice win or Bob win? Will Alice win or Bob win? Suppose the Grundy values are already known. Then how can you check will Alice win or Bob win? Any guesses? Yeah, so suppose you have only one element. So if there is only one element and suppose its value is I, then you will simply check that, okay, is Gi equal to 0 or not? If Gi is 0, then we will lose. If Gi is not 0, we will win. That is completely fine. But now even you have an array. So if you have an entire array, then how to understand that, okay, will Alice win or Bob win? So that is what Grundy's theorem says, that if you have a lot of problems which are dependent on each other, so basically you have this state, and for this state you have a Grundy value. For this state you have a G value. All of these are computed. But now I ask you that for all these values combined, who will win? Then you basically need to take the bitwise XOR. So you take the bitwise XOR of G of A1. So basically you compute this value G of A1 XOR G of A2, and this goes till XOR G of AN. And then you basically check is it 0 or not. If it is 0, then we will lose. If it is not 0, then we will win. This is what the Grundy's theorem says. Fine. So whenever you have a lot of problems which are dependent on each other, then you can take the bitwise XOR of those values. And if it is 0, then we will lose, else we will win. Fine. So this is basically the statement of Grundy's theorem. So now the question boils down. So what does the question said? So the question said that you are given some array A1 till AN. I have already shown how we will compute these Grundy values. Those are computed for those are computed. And now for some range L to R, you need to tell me how many subsequences are there. How many subsequences are there for which Alice will win, right? So that basically means how many subsequences are there in this range for which the bitwise XOR is not equal to 0. So that is the question. How many subsequences such that Grundy values are not equal to 0? Such that XOR of G values not equal to 0. That is the question which has been asked. But now it is not a very simple question, because then you have to also handle updates where you will simply remove an element, update an element, right? So whenever you have to do things like this, the best idea is using a segment tree. So somehow you have to use a segment tree and you have to write a merge function. So you have to write a merge function so that whenever you have two ranges and you know the answer for those two ranges, you can actually find the answer for the larger range. If you can do that using a segment tree, if you can implement the merge function, then you can do this. So any idea how to implement the merge function? How can we use a segment tree to find that in a range how many subsequences are there with bitwise or equal to 0? Okay, so basically what is a segment tree? So a segment tree is a data structure. So probably this question actually had a lot of prerequisites. Basically, what is a segment tree? A segment tree is a data structure which basically says that, okay, if you have some range L1 to R, L to R, and you need to find the answer for some range, and then you also need to handle queries where you will abruptly come and change some index to some other value X. So for example, you are given some array A1 to AN, and you need to handle two types of queries. One query is that for some range L to R, tell me their sum. Okay, tell me their sum. This is one query. And the second query is change the value of AI to X. Okay. Now note that if this second query was not present, then this first thing can be simply done using prefix sum, right? But now since the second query is present, you cannot use a prefix sum. Basically, in that case, this question can be actually done using a segment tree. And if both of these queries can be handled in log n time using a segment tree. So while using a segment tree, the most important property is that you are given two ranges L and R. So I suppose I've given this range L1 and R1, and I have been given again one more range, say L2 to R2. I have to combine information from this and information for this to compute the answer for the entire range L and R. If you can ever do this, you can actually write a segment tree. So for example, in the sum question, if you know the sum of this, so if you know the sum of this sum 1 and you know the sum of them sum 2, then you can add up sum 1 and sum 2 here, and you say that, okay, the total sum of this range is sum 1 plus sum 2. So for sum, writing the merge function is very trivial. Whenever you can write the merge function, you can actually use a segment tree to optimize queries and perform them in logarithmic time. So in this question, we need to compute for some range L and R, so given a range L and R, how many subsequences are there? How many subsequences are there with XOR equal to 0? So basically, you would be given an answer on two smaller ranges L1, R1 and L2, R2. So you are given L1 R1 and L2 R2, and you need to find the entire answer for the bigger range LR. Okay. So what information can we store in the segment tree so that we can actually merge the answers from these two arrays and find out the answer for this? It seems that basically I know the Grundy values are small. The Grundy values is basically the mix of 5 or 6 digits. So it will never exceed, say, 8. So if the Grundy values will never exceed 8, it makes sense to store a frequency array here. So in the segment tree, in the node of a segment tree, I will store a frequency array f of size 8. So if I will store that how many subsequences are there in this range which have the XOR equal to I. So in this frequency array also there will be stored how many subsequences are there which have say XOR equal to j. So now if I know the number of subsequences with XOR I here and the number of subsequences with XOR j here, I can, for all I and j from 0 to 8, I can actually also compute the frequency array here basically. So if you look at the code, okay, so if you look at the code, look what I've done. So this is actually usually a non-trivial implementation of a segment tree. So I have made a segment tree where every node of the segment tree contains a vector of size 8. So what do? I basically, every node of the segment tree contains a vector of size 8. So what does that node store? The node corresponding to the range LR basically is a vector of size 8. So f of I stores that how many subsequences are there which have XOR equal to I. So in the merge function, I am trying to merge A and B. So if I know that how many subsequences are there with XOR I in A, and I have these frequency arrays ready. So look that I can simply iterate over I and J. And then I could say that, okay, there are AI number of subsequences with XOR I in the first half. There are BJ number of subsequences with XOR J in the second half. So all these two subsequences will XOR up to give the value of I XOR J. So I could simply write that, okay, V I XOR J is addition of this. Apart from that, I could also ignore one half and take the subsequences of the other half, as subsequences of one half completely inside one half is also part of the larger subarray. So that is the reason this is how you implement the merge function. So once you implement the merge function, the rest of the part is simply template code. I just in the second part of the query, I just update segment tree like that, and in the first part of the part, I just simply query the segment tree to get the answer. Also, here we are counting the number of subsequences where the XOR is 0, right? But if the XOR is 0, that would basically mean that, okay, Bob is winning. But we need to compute the number of subsequences in which Alice is winning. So we basically subtract it from 2 to the power n. So 2 to the power n is the total number of subsequences minus the number of subsequences where Bob wins minus 1, because we do not consider the empty subsequence. We need to consider non-empty subsequences. Okay. So probably, so this question actually had a lot of prerequisites. First of all, it had a very non-trivial implementation of segment tree. Usually segment tree implementations are clear. You just have basically a max. You find max or something where you do not need to understand how the segment tree internally works. But here, since you have to write a custom merge function, we had to understand that how the segment tree works, or how can you merge two nodes in a custom fashion. Apart from that, to handle the game thing, we also required Grundy's theorem and a lot of important facts regarding it, that how to compute Grundy's theorem using transitions and what do they mean. So probably there were a lot of prerequisites for this problem. But I hope the basic idea is clear, right? Yeah, Anurag, like probably this was, I read about Grundy's theorem once in a while as a part of the theory, but believe me, this was the first time I ever solved a problem on Grundy's theorem ever. So like this was the first time I have encountered myself this. So it is no problem if you have not seen a problem on this topic. It's completely fine. Okay. So that's all for today. Let me stop the recording.